Welcome to part 2, Differentiation of Inverse Trigonometric Functions. We're looking specifically at being able to tackle questions in exercise 13.7, namely questions 2, 3, 4, 5, odd parts only. Your prior knowledge, you need to be able to recognize if a problem involves the product and or quotient rule. Number 2, you need to have learnt how learnt and can apply the product rule. You need to have learnt and have been able to apply the quotient rule and differentiate inverse trig functions, which we did in part 1. And this is just a summary page of all that. We're now moving on to the example, which is y is equal to 3x multiplied by cos inverse. So what we have here is we have a product. The product is 3x on the function cos inverse of x over 5. So as soon as we recognize it's the product rule, then we're going to be using this formula. And because we're using this formula, we need to start labeling up our functions. So I'm going to call the 3x the first function. I'm going to call the cos inverse the second function. And over here, I'm going to write down function number 1 is equal to 3x. And the differential, this is coding for it, just to make it quicker and easier, differential of function number 1 will be equal to 3. And then function number 2 is going to be equal to the cos inverse of open bracket x over 5. So we're going to be using the formula up here. And we can already see that the question matches the formula. The x is equal to x and the a is equal to 5. And because of this, we can actually go straight to the differential. So the differential of the second, we're going to use the formula, is minus 1 over the square root of a to b squared minus x to b squared. And we can clearly see that the value of a is equal to 5 and the value of x is equal to x. And if we differentiate this, to work out the multiplying factor like we did in part 1, we can see the multiplying factor is in actual fact 1. So the differential of the second function is going to be quite simply minus 1 over the square root of a, which is 5. 5 squared is 25, minus x squared, it's quite simply x squared. So what we're going to do now is we're going to put it all together. So we're differentiating the y. When we differentiate the y, we are going to get dy by dx. And then we're going to start applying this formula. First times differential of second plus the second times the differential of the first. Now this is my preferred way of writing it, as long as I say it in words. What is my first function? My first function is up here, and it is 3x. What's the multiply by? What's the differential of my second function? Well, the differential of my second function is going to be minus 1 over the square root of 25 minus x squared, plus the second function. What is my second function? Well, my second function is this, and that's going to be cos inverse of x over 5 multiplied by the differential of the first function, and the differential of the first function is 3. And this is the end of the problem. So dy dx dy dx is equal to 3x and minus 1 is going to be minus 3x all over the square root of 25 minus x squared plus, and we're going to bring that 3 to the front, so it's going to be 3 cos inverse x over 5. And that's the end of the first example. Moving on, slightly more complicated example. Once again, you can see it is a product rule because the first function is 3x plus 6 multiplied by the second function, which is the sine inverse of 5x over 3. Okay. Once again, we know it's the product rule and some multiplication, so we are going to be using the product rule. So in our heads, we know it's going to be the first times the differential of the second, plus the second times the differential of the first. But when we write down the product rule, we abbreviate it as we're saying it. So dy dx is equal to the first times the differential of the second plus the second times the differential of the first. So what we have to do now is do all the mathematics for it. That's what we have to do now. So what is the first function? The first function is equal to 3x plus 6, and the differential of the first function is equal to 3. The important thing is, if you do recognize it is a product rule and you do something right, you are going to get marks on this. This we regard as being quite a hard question, but it's so easy to actually get attempt marks and pass the question, even if you don't get the whole question right. The second function is equal to the inverse sine of open bracket 5x over 3. And straight away we know it's going to be making use of this one here. And from that we know that the x in the formula is equal to 5x. When we differentiate this, based on part 1 mathematics a couple of days ago, we end up with 5, and 5 is the multiplying factor. You will lose 3 marks if you fail to identify the multiplying factor. Okay, moving on, the value of a, it's the value on the bottom, so the value of a is 3. We're now going to apply this formula. So the differential of the second function is going to be equal to 1 over the square root of a squared. Well, a squared is 9 minus, and what is the value of x? It's 5x. And what is 5x squared? What is 5x all squared? Well, it's going to be 25x squared. So it's minus 25x squared. And this is the part where people lose 3 marks. They forget to calculate the multiplying factor, and they forget to multiply the top of this by 3. So now we're going to put all this together. This is what, 15 mark question. So at the higher end. So putting it all together, dy dx is going to equal, what's the first function? Well, the first function is 3x plus 6. When you're substituting, remember what we say, substitute into brackets. 3x plus 6. And then it's going to be multiplied by the differential of the second. Well, the differential of the second is going to be this thing here, which is going to be 1 times 3 over the square root of 9 minus 25x squared. And then it's going to be plus the second function. The second function is this one here, which is going to be sine inverse of 5x over 3 multiplied by the differential of the first, which is 3. And then you do your tidy up line. So dy dx is equal to, well, 3 times 1 is 3, and then times it onto the bracket, so it's 3 on 3x plus 6 all over the square root of 9 minus 25x squared plus, bring the 3 to the front, sine inverse r 5x over 3. And that's the end of example number 2. The setting out is absolutely vital. Full A4 page. Going on to the next example, we can see this is a quotient. Quotient meaning division, and we have a division problem here. So we're going to be using the quotient rule, and therefore we're going to be quoting this formula here, but we will never write it out in full like that. We will just write it out as dy over dx is equal to the bottom times the differential of the top minus the top times the differential of the bottom all over the bottom to be squared. Again, we'll do it in a different colour, just so as it stands out, doesn't clash with what we've got here. The top function, do it here. The top function is equal to tan inverse of x over 2. So we're going to be using this formula down here. So we know that the value of the x is going to be x. We know the differential of this will be equal to 1. So the multiplying factor will be equal to 1. The a is going to equal 2. So all we've got to do now is apply this formula. So the differential of the top is equal to, well, what's the value of a? Well, the value of a is 2. And then in your head, what's 2 squared? Well, that's going to be 4. And what's x squared going to be? Well, that's just going to be plus x squared. So that's the top and the differential of the top done. And now we're looking at the bottom, which is 2x plus 1. And the differential of the bottom is just going to be 2. Now, all we've got to do is apply it. So we have dy over dx is equal to, what's the bottom? The bottom is, open bracket, 2x plus 1, multiplied by the differential of the top. And the differential of the top is 2 over 4 plus x squared minus the top. And the top is tan inverse x over 2 multiplied by the differential the bottom is 2. And then this whole expression is divided by the bottom squared. And the bottom is 2x plus 1. So it's 2x plus 1 all squared. So possibly one tidy up line. Dy over dx is equal to 2 on 2x plus 1, all divided by 2x plus 1 to be squared, minus, now be careful, silly mistake is people go 2 times x over 2 and cancel out the 2's, which would be wrong. That's inside the inverse tan function, so you can't bring the 2 in. So the only place you can bring that to is to the front. So it's 2 on tan inverse x over 2. Possibly one more line of working out. It's a difficult one. Dy by it's not a difficult line to work out, but it's difficult to decide whether you get any more marks for it. 2x plus 1 all over 2x plus 1 squared minus 2 on the inverse tan of x over 2 all over 2x plus 1 all squared, and one of these cancels with that, so you end up with one last line of dy over dx is equal to 2 over 2x plus 1 minus 2 on the inverse tan of x over 2 all divided by 2x plus 1 all squared. My gut feeling is full marks for that line there. Okay, we're looking at now is this example here, and once again we can see it's a quotient rule, and because it's the quotient rule in our heads we will be saying this following rule. What we'd be physically writing down is dy dx is equal to the bottom times the differential of the top minus the top times the differential of the bottom, all over the bottom to be squared. Up here we'd be writing the top is clearly 3x squared, and the differential of the top is clearly going to be 6x. Easy enough done. The bottom is going to be cos inverse of x over 3, and now we're going to work out differential of the bottom. Now we know that the x, when we compare it to the formula, is equal to x. The differential of this x is going to be equal to 1, so the multiplying factor is equal to 1. The number on the bottom, which is the a, is 3, so a is equal to 3. So now we can apply this formula here. So differential of the bottom is going to be minus 1, because you can bring that minus and put it into here, all over the square root of the a to be squared. Of course a is 3, so squared is 9, minus x to be squared, which is going to be x squared. Once we know that, then we can get on and substitute it. Now, I have been up till now doing that in blue, so just to make it easier to distinguish the working out from the main part of the question. So I'll quickly change all that to blue. Okay, let's get on with the next part of the problem. which is just applying it. So we're now going to apply it and just move it down here a small bit just to give ourselves a bit of space. So dy by dx, dy by dx is equal to the bottom, and the bottom is cos inverse of x divided by 3 multiplied by the differential of the top, and the differential of the top is 6x, minus the top, and the top is 3x squared, times the differential of the bottom, times the differential of the bottom, which is minus 1, better put that in brackets, all over the square root of 9 minus x squared, all over the bottom, which is cos inverse x over 3, all to be squared. And technically, that is the end of it. That's the problem finished. A little bit of tidying up though. Dy dx is equal to 6x on cos minus 1 of x over 3, just bringing the 6x to the front. I'm going to bring the minus to the front, and I'm going to get a plus. 1 on 3 is 3, so it's going to be 3x squared on top. On the bottom is going to be the square root of 9 minus x to be squared. And then that whole thing, the whole lot, is going to be divided by cos inverse of x over 3, and then round that is all squared. That's the end of that particular problem.